Okay, so in this question we are asked, what is the solubility of lanthanum 3 iodate in a solution that contains 0.1 molar iodate ions? And we're given the KSP of lanthanum 3 iodate. So this is a problem about common ion and how a common ion affects solubility. So just like before, we've done problems like this. We want to start with the reaction that occurs when this solid dissolves. So it will break apart in a reversible way into its component ions. So you get the lanthanum 3 plus aqueous, and you get 3 of the iodate aqueous. Okay. And that becomes the reaction in our table. And we'll just set up the table to calculate the solubility. We'll make our rows and our columns. And again, we leave out the column for the lanthanum 3 iodate because it is the solid. Now, what we're going to do a little differently, because this is a common ion question, is we are not going to put both zeros in these two blocks. So we originally have 0 amount of the lanthanum 3 plus ions because their only source is this salt that I'm trying to dissolve. But we're told that we already have 0.1 molar solution of the iodate, so that's going to be the number that I put in that block. Okay. But the change is the same. It's still going to shift to the right because nature's not going to like the fact that I have 0 amount of these lanthanum ions when I have this reversible reaction. So it's going to shift to the right, and so I'm going to lose X amount of the solid to gain X amount of that ion, and then 3X amount of the iodate, because for every one of these that I dissolve, I produce 1 of these and 3 of these. So I bring the columns down, and this becomes a X, and this becomes a 0.100 plus 3X, right? And so the next thing that I need to do is I need to write the expression for my solubility product, the equation. So that's going to be equal to the concentration of each product multiplied together raised to the power of its stoichiometric coefficient, so that 3 becomes an exponent of 3 in my equation. Now that would also need to go over, that would be the numerator, and my denominator would be the reactant side, but since we leave solids and pure liquids out of the expression for the equilibrium constant, all equilibrium constants, I don't include that in this expression for the KSP. So now I can just substitute in these terms into my equation for KSP, so that becomes X times 0.100 plus 3X quantity cubed, and all of that is equal to the value of the KSP that I'm given, so it's equal to 7.5 times 10 to the minus 12. Okay, so now we're just going to take that, and you can plug that into your calculator, and you solve for X. Okay, and when you do, you get that X is equal to 7.5 times 10 to the minus 9. Now if you go back up here to your table, you see that X represents the amount of this compound that dissolves, and that's what we're being asked to find. What is the solubility of that compound? How much of this will dissolve? Well, that's equal to X. So we'll put units of molarity on that, and that's going to be our answer. That is the solubility of lanthanum 3 iodate when you have 0.1 molar of the common ion present.